another one of my Leetcode videos. It's been a while since I've done one, but today I've picked a dynamic programming problem, which is called house robber. Here's how it goes. You are a professional robber planning to rob houses along a street. So there are houses along a street, and each house has a certain amount of money, and the only constraint is you can't rob two adjacent houses because it'll alert the police and all that. So you're basically given an array of numbers. Each number represents the amount of money in the house, and the only constraint is you can't rob two adjacent houses. So in this case, if you rob one, you can't rob two, and so you rob three, and so 1 plus 3 is 4. If it was something like 1, 2, 3, 8, you would probably go and rob 2 and 8 or something, so that will be 10. So yeah, you get the idea. So the way I approach this kind of problem is I usually write down a mathematical model, right? There are multiple ways to solve this. You can do memoization and recursion, or you can do it iteratively so that it doesn't take extra space. So let's say let's define our mathematical model. So let's say our max money robbed, if we start at the node I. So let's so if I start robbing at this house, what's the max money I can rob, right? So I have two choices. Either I rob this house, or I don't rob this house and I go to the next one, right? So if I'm starting at a node I and I rob it, then the money I get is basically nums at I plus the max money robbed at I plus 2, because remember, I cannot rob I plus 1 if I rob I, right? So it's gonna be either that, or I just start robbing at I plus 1, which is basically just the max money robbed if I start at I plus 1, right? So this is a recursive function. It basically says the max money I can rob at I is either if I rob I plus the max money I can rob at I plus 2, or it's just I skip I and it's the max money robbed at I plus 1. So this ensures that there are no adjacent houses robbed. And so now if you look at this equation, so we have max money robbed at I. So at the end of the day, we just have to return max money robbed 0. But in order to get max money robbed 0, we need max money robbed 1 and max money robbed of 1 plus 2, which is 0 plus 2, which is 2, which we don't have. So the idea is we'll first compute the max money robbed at the end, right? So the max money robbed if you start at the last house, which is basically going to be nums.length minus 1, right? So if you start at the very last house, you only have one choice, is basically you just rob it, right? So the max money that you can rob at that, if you start at the last position, is basically just this, right? And then the max money robbed if you start at 1 before the last position, we need at least 2, because this one says I plus 2, right? So we need at least the last 2 pre-calculated, right? So the second last position is just going to be nums.length minus 1 minus another 1, which is going to be minus 2. And this time, if I start at the second last position, I basically have two choices. Either I rob this house or I rob the next one. So whichever is higher, right? So it's going to be max of nums.length minus 1 comma nums, just to make it less confusing, nums.length -2. So once these two we can easily compute because we have the nums array given, right? So the only thing in these two is the nums array, and then we can compute nums.length -3 to 0 using this equation, and all we need to keep track of is I plus 2 and I plus 1 and plug it into this equation. So yeah, let's take care of some edge cases first. If if the nums.length is just 1, we can't compute the -2, it'll overflow. So let's just take care of the base case, which is basically if nums.length is equal to 1, then we just return nums at 0, because if there's one house, the maximum money you can get is just if you rob the house itself. So that's the base case, and now let's use our formula. So first, let's compute the last one, which is going to be the I plus 2 of this one. So it's going to be, let's just name it I plus 2. It's going to be nums at nums.length -1, and then the I plus 1, and I here is referring to the third last one because that's where we'll start our loop. So we pre-compute I plus 2 and I plus 1, so we can start plugging it into this equation. So our I plus 1 is going to be the max of that and nums.length -2, and note that this will not overflow because from here we've already guaranteed that nums.length is at least 2, since 1 can be the minimum. So our I plus 2 is this, our I plus 1 is this, and now we just plug it into our loop. So for int I is equal to nums.length, so we already have the -1 and -2, so our next one will be, we start from nums.length -3 and we go all the way up to 0, right? So if there are only 2 elements, then we'll end up returning this one. And so we keep going till 0, I plus plus, and so what we do is, we say int max at I is equal to, we just basically use this formula. So math.max of either nums at I plus the I plus 2 and I plus 1, right? So it's either we rob the current house and add I plus 2, or we just take I plus 1. And once we have the max at I, then our I plus 2 will now be equal to I plus 1, and our I plus 1 is now equal to max at I. So this is preparing for the next iteration. And at the end, I plus 1 will contain the value for max robbed of 0, because this will be when I is 0, this will be set to the 0th index for this max money robbed, and I plus 1 will contain max at I. So at the end, we can just return I plus 1. And note that if there are only 2 elements in the array, I plus 1 will contain the 0, because 2 max robbed of nums.length 2 minus 2 will be max robbed 0, which is initially I plus 1. So with that, our time complexity is O of n, because we just looped through the array once, and our space complexity is O of 1 because we only have 2 extra variables um, that we're using. Let's try to run this. Hopefully it compiles. Oops, index out of bound exception. So let's see. Oh, it should be I minus minus, not I plus plus, because we're going backwards. Accepted, and let's submit. Cool. It's the fastest solution. So yeah, I hope you enjoyed this video, and I'll see you in the next one.